In section 3.2, we're going to look at graphs of functions, and I want to reintroduce these four concepts. So domain we talked about before, and that's all with the whole function. I'm going to call our function f of x. All the possible values that x can take on. And the range is all the possible values that get mapped to, so those are all the possible values of y, or f of x. And then the increasing, decreasing, and constant, to determine which intervals are increasing, decreasing, and constant, we think about the slope. So we always read the graph. I'm going to put this over here. Read the graph from left to right, just like when we read English, and it's increasing when the function is increasing when the slope is positive, or when it's going uphill, so when m is greater than 0. And the function is said to be decreasing on the interval where it's less than 0, or a negative slope. And constant is when that slope is equal to 0, like a flat sidewalk. And then the last topic from this section is evaluating. So, for example, if we want to look at a graph of f of 2, then we go to the graph, whatever it is, and we go to 1, 2, and we go see what that y value is. And whatever that y value is f of 2. All right, so let's apply this to an example, these four topics. So we're going to consider the following graph of a function. So this relates to your homework from exercises 25 to 36. So the first thing we're going to do is find the domain. So the domain is all the possible x values. So I can see this function starts in negative infinity because I have an arrow that tells me it goes forever left. So it starts at negative infinity, and the x values, it follows along this line. But notice all the x values are counted for. There's somewhere, any x value going along here is something on the red line. All the way up to here where I have a stop. And there's no arrow, so I know it's going to stop at 5. So I know there's a break right here, but I'm going to assume this graph is mapped at units, a single unit, the scale. So at x equals 2 it's defined, and then as soon as it passes 2 it's defined over here. So still, x is still defined on all those. All right, now let's go to the range. The range is all the possible y values. So the lowest possible y value on this graph is this negative 3 right here. So it starts at negative 3, and it includes negative 3, and it's going to go up to, let's see, the high. Now notice that all these y values, they have some point that corresponds on the red line. There's no gaps. And it goes as high as 2, but does not quite include 2, because the highest y value ends right before that 2. So it goes up to 2, but not including 2. Okay, now for C, we need to look for where the function is increasing. Oops, I don't want green. Let's do increasing in orange, and then we'll do decreasing in I don't know, yellow, if that's easy to see, and then constant in brown. So where is this graph increasing? Whenever the slope, I'm going from left to right, remember always go left to right, and it's if you're walking along this red line, when are you walking uphill? And that is right here, and that's really it. That's the whole increasing interval. So that starts, the increasing starts at remember our intervals are always x values. Well, not always, because the range is. the range is actually y values. But our increasing, decreasing, and constant intervals, these are going to be the x values. So the x value starts at 0 and goes to 2. I don't include 0 or 2 because it's not increasing on the endpoints. And then the decreasing so if I'm walking along from left to right on the red line, I'm walking downhill, let's see, 2 places, right here and right here. So from this one, it looks like I'm going from -1 to 0. And a little more space here. So -1 to 0. And then I'm decreasing again at for the next yellow line, starting at 2 and ending at 5. And again, I don't include the endpoints for these because I can't increase in a 1 point. And then I want to include both intervals, so I'll do my union there. And then constant is in brown, so that is a horizontal line. There's no change. So constant, and the x values for its constant is right here. So that those x values are from actually negative infinity, right? Because this has an arrow, so it actually goes on. It starts forever ago. So negative infinity to looks like it stops at -1. All right, so those are my intervals. And again, those intervals are always expressed with the x values. That's the independent variable. All right, and then the last thing, part D. Let's do purple. I'm actually going to erase all these lines for part C, so oh shoot, then I erased my graph. Never mind, that's a bad idea. So I'm going to have to leave those lines because or else my graph will go away. All right, so D, I want to evaluate f of 0. So I go to the input of 0, so x equals 0, and I go what is y equal to at that point? And I can see the y, when x equals 0, y equals -3. So that corresponds to the point 0, -3. And then for E is f of -2. So I go to my graph and look at -2. When x equals -2, what is y? Y is -2. And f is finding f of 2, so that means plugging in 2 for x, which is right here, and that closed dot is right there on the x-axis. Remember, it's an open dot over here. When I plug in a 2, I get my output is the y value is 0. That corresponds to the point 2, 0. So these are the answers. All right. So that is my example for 25 through 36.